Hello, welcome to Algorithms. In this episode, we are going to discuss about automation of enterprise BI with Azure Synapse Analytics and Azure Data Factory. If you remember, in the previous architecture, we discussed about the basic building blocks. Now we are making it complicated and reflecting it more of a real world use case. So let's go to the scenario. We have made some changes. Rather than having just a SQL Server database on premises, we have an external data source. For orchestration of data pipeline, we are using Azure Data Factory, and apart from the orchestration, we are looking at the automation as well. Azure Active Directory for identity and access management at the analysis services and Azure Synapse Analytics level, so that whenever a Power BI user is trying to access analysis services, they get authorized and authenticated based upon the rights they have on the system. Now we will look at four different aspects: automation of pipelines using Data Factory, incremental loading. Now if you have a database, you don't load data every day. I mean to say full load. So you look at what are the options, why you should be doing incremental loading. Similarly, integration of multiple data sources, loading binary data just such as geospatial and data images. We will not go into details but have a brief look how we can address some of the challenges that arises when you use different tools when you process this kind of data types. Data sources, we know we discussed about this in the first presentation. External data source, as I said, this is a very common scenario in which your data warehouse is integrated with the multiple data sources which are located in different regions. Now in this case, you can assume that this external data set contains city population by year and integrates it with the data from OLTP database. Ingestion and data storage, we are using blob storage, Azure Synapse Analytics and Azure Data Factory. I'm sorry, I did not move to the high level architecture. And analysis and reporting, Azure Analysis Services and Power BI. As I said, Azure Active Directory for authentication, and Data Factory can also use Azure Active Directory to authenticate to Azure Synapse by using a service principal or managed service identity. Now look at the data pipeline. So when we discussed about the presentation in part 1, so that's the reason I have given this snapshot from the old presentation, which reflects the flow from the part 1, where we have on-premises and then we have Azure and how different activities are happening at each stage. And now in this one, we are talking about data pipeline, which is representing Azure Data Factory on the left side. So as you know that in Azure Data Factory, a pipeline is a logical grouping of activities used to coordinate a task. In this case, loading and transforming data into Azure Synapse. So this reference architecture defines a parent pipeline that runs a sequence of child pipelines, and each pipeline loads data into one or more data warehouse tables. Okay, now let's discuss about the incremental loading. Now when we talk about incremental loading, we have different options. So for instance, if you want to automate ETL or ELT process, the most efficient way to load the data is that you should look at what has changed since previous run and load only that information or data points. So this is called an incremental load as opposed to full load that loads all the data. So to perform an incremental load, you need a way to identify which data has changed. The most common approach is to use a high watermark value, which means tracking the latest value of some column in the source table, either a date time column or a unique integer column. Now, if we go back, starting with the SQL Server 2016, there is an option of using temporal tables. So these are system version tables that keep a full history of data changes. So the database engine automatically records the history of every change in a separate history table. You can query the historical data by adding for system underscore time clause to a query. Internally, the database engine queries the history table, but this is transparent to the application. And these temporal tables are useful for dimension data which can change over time. Fact tables usually represent an immutable transaction such as sales, in which case keeping the system version history does not make sense. Instead, transactions usually have a column that represents the transaction date, and that can be used as the watermark value. Okay, now those who are familiar with the SQL Server 2016, let's talk briefly about change data capture as well. So before SQL Server 2016, you had a feature called change data capture that can be used, but this approach is less convenient than temporal tables because you have to query a separate change table, and these changes are tracked by log sequence number rather than a timestamp. So that's why temporal table is more efficient compared to change data capture. So if you are running SQL Server 2016 or above, you can look at enabling these options rather than going back to the CDC. Okay. From the data cleansing perspective, I don't think it makes more sense to have a discussion here. Handling large binary data. So if your database contains city table that has location column that holds a geography or a spatial data type, which is a very common scenario in in a lot of e-commerce application, plus other microservices applications as well. For instance, cab services like Uber, they capture geographical spatial data types or geography spatial data types. So Azure Synapse does not support the geography type natively, so this field has to be converted to var binary type during loading, and this is an important point. I'm sure Microsoft will add geography or spatial data type sometime in future, but at this point of time it is not available. That's one thing. Number two, Polybase supports a maximum column size of var binary 8000, which I am re-emphasizing again. I did that in the previous presentation as well, which means that some data could be truncated. So a workaround for this problem is to break the data up into chunks into export and then reassemble the chunks. So for instance, you can create a temporary staging table for the location column. For instance, for each city, split the column data into 8000 bytes chunk, and then you reassemble the chunks using T-SQL pivot operator to convert rows into columns and then concatenate the column values for each city. Now the challenge is that each city will be split into different number of rows depending on the size of the geography data. For the pivot operator to work, each city must have the same number of rows. To make this work, T-SQL query does some tricks to pad out the rows with a blank value so that every city has the same number of columns after the pivot. So there are some sample queries which are given by the Microsoft. You can have a look at it online. If not, just please drop a comment in the comment section and I'll share those queries with you as well. Now, slowly changing dimension is also one of the topic which is very common when we are talking about SQL Server data warehouses or any sort of data warehouses. So the common technique is type 2, which is to add a new record whenever a dimension changes. Okay. So the advantage of this approach is that it preserves the historical data, which can be valuable for analysis, because this question comes up several times during the discussion with the experts in different organizations and consulting engagements that, okay, do we need to make any changes? So we do ask these questions, or this is part of questionnaire, what sort of slowly changing dimensions you have in your data warehouse or enterprise data warehouse. And then we look at it. Some It really depends, means it's not that always they have type 2. Their use case might support type 1 or type 3 also, but it really depends. So but type 2 there is a lot of flexibility, that's one of the reason. Okay, now from the security consideration perspective, this is very important. uh, if you want to keep your environment more secure in Azure, you can create or you can use virtual network service endpoints to secure Azure services resources to only your virtual network. And this fully removes public internet access to those resources, allowing traffic only from your network. And so what is happening, or what I'm talking about, if the service endpoints are enabled for Azure storage, Polybase cannot copy data from storage into Azure Synapse Analytics. So there is a mitigation for this issue, and that I'm going to cover in a different presentation, or you can search online. But this is a problem, this is an issue. If you are enabling uh, uh, virtual network service endpoints for your virtual network, it will be difficult for, or there will be issue with the Polybase as well as ADF copy command. So you will have to be cognizant of this fact. Now to move data from on-premises into Azure storage, you need to allow public IP addresses from your on-premises or express route if you are using express route. Now third point is to enable analysis services to read data from Azure Synapse. Deploy a Windows VM to the virtual network that contains the Azure Synapse service endpoint. Now this is something which is very specific when you are considering a highly secure environment, which obviously every customer is going to, but you have to make sure that that these 3 points are considered, and whatever mitigation I just mentioned is included as a part of checklist or part of project management activity, that these are the tasks that has to happen in order to make sure that you don't feel that you missed out something that you should have done right in the beginning while implementing this architecture. Now from the pricing perspective, let's look at some of the examples. So for instance, how pricing works for Azure Data Factory. So consider a use case where there are lookups activities from two different sources. One takes 1 minute and 2 seconds, rounded up to 2 minutes, and the other one takes 1 minute, resulting in total time of 3 minutes. So two lookup activities, one lookup activity take 1 minute 2 seconds, and the second lookup activity take 1 minute, so the total is 3 minutes. And then there is a one data copy activity which takes 10 minutes, and then you have a stored procedure activity that takes 2 minutes. So the total activity runs for 4 minutes. Now you have activity runs, lookup, stored procedure, and data copy. These are the 4 different categories. Now what you need to do is you need to check the prices of these 4, and similarly you can create a table, and there is a calculator called Adf Pricing Calculator. You put all these activity, number of activity, and then the price, and then you get a complete price. So for instance, how many DIUs you need, for instance data integration unit, and that gives you the total cost per pipeline run once per day for 30 days, and run once per day per 100 tables for 30 days. So there are different permutations and combinations that you can apply to come up with the estimate. and that you can share as a part of your cost analysis and benefits from the architectural perspective. Azure Synapse again means it is ideal for intensive workloads. If you are going for 1 year reserved plan, you save 37%, which is actually according to the Microsoft website. If you are going for 3 year reserved plan, then you can save up to 65%. Now data storage is charged separately. Other services such as disaster recovery and threat detection are also charged separately. So if your solution or your architecture contains or if you need disaster recovery or threat detection, you need to add those costs in the cost analysis services. Generally, when you do a POC, it is recommended that you use an evaluation version, but there are other tiers which are basic and standard tier. So basic is recommended for a small production environment, and a standard tier is for mission critical production workloads. So, and no charges apply when you pause your instance. Okay. Blob storage, I guess everybody knows how blob storages are calculated. Consider using blob storage reserve capacity feature to lower cost on storage, which is a kind of a no-brainer. So with this model, you get a discount if you can commit to reservation for fixed storage capacity for 1 to 3 years. And this is very common for a lot of services, not all of them. Okay. I guess this is it from my side. I know I switched the slide before I completely explained the previous one, so I'm sorry about that. And if you like this video, please like it, subscribe it, and leave your comments in the comment section about the areas which I can improve. Thank you very much. Have a good day.